Welcome to another episode of Arduino 3D Thursday, where I present a project related to an Arduino-based module and, if possible, a 3D printer model with it. This is Ron from emicros.com. Now let's get started. In this episode, I'll start writing code for the CanWiser Lite module that I had built and assembled in the last episode using surface mount devices. The need for speed is how I wrote some code to speed up the communication with the MCP2515 CAN controller IC. In this project, I'm adding a few functions to speed up the interface to the MCP2515 controller area network IC from MicroChip. This is part one of a two-part series. In the last episode, I laid out and built, for me, the CanWiser Lite module, which uses the Seeed Development XIAO ESP32C32 module connected to a MicroChip MCP2515 CAN IC. When I started writing software for it using the MCP CAN library, I realized that some new functions could be added to speed up the communication via the SPI channel. The board I had built and assembled had a couple of defects. I forgot the pull-up resistor on the reset line, and also found out that the ESP32C3 doesn't like 5-volt inputs. So I redid the board, adding a pull-up resistor, and changed the MCP2515 voltage from 5 volts to 3.3 volts. It worked. Now let's get to the software. Start with a new sketch and add a timer highlighted in yellow. Next, we want to add some timer code to the setup function. You can see it listed here. And then we want to add the timer interrupt ISR function before the setup function. That is shown here also. Notice in the onTimer function, the timer 1ms counter is incremented until it reaches 10. Then we reset it to 0, and a 1 millisecond flag is set. This is used in the main loop function as a scheduler. In the loop function, the 1 millisecond flag is checked, and if set, it is reset to false, and for now the LED pin is toggled. Using a scope, there appears to be something causing the 1 millisecond timer to be held off. I'm not sure what causes this, but in the loop function, if I add a for statement to prevent it from returning, this seemed to solve the issue. And you can see that here. We have a clean scope plot now. This is showing the for loop. Now we'll add the MCP CAN library. The interface to the MCP2515 uses a SPI, so both the MCP CAN.h and SPI.h header files are included. Those are shown here. The chip select pin for talking to the MCP2515 is D6, and the interrupt pin is D5. The MCP CAN class is used, and we can use it as CAN0. The following is added to the beginning of the file. Next, we add the following to the setup function. Notice that the serial channel has been added as well, since in the CAN0.begin function we're going to print a success or a failure message. Also, we set the mode to normal. In the loop function, when the 1 millisecond timer triggers, a CAN message is sent using the CAN0.send message buffer function. The LED is set high before this function is executed, and then set low afterwards, so that we can use a scope plot to measure how long this function takes. This is showing the function. From the scope plot, the time to send a CAN message using the MCP library is 360 microseconds. This is fine, of course, but I challenged myself to improve on this, which will be discussed in part 2. Stay tuned, and thanks for showing an interest in this. See you in the next part.